In this lesson, we are going to discuss how to implement batch resource creation in a REST API. This is a topic that's somewhat problematic in the context of REST because there are multiple ways to approach it. So I'm going to demonstrate my pragmatic approach, and we're also going to discuss what are some of the alternatives that we could have chosen and what implications they have for our implementation. If you navigate to the entries controller and head over to the create entry batch method, you will find our post endpoint for creating a collection of entries in one API request. So the first thing I want to discuss is how to approach exposing a batch creation endpoint on a REST API. What I did here is expose a new resource. It's the entries batch resource, and it uses the post HTTP method. I think this is the most pragmatic solution because it doesn't overcomplicate our REST API design, and it clearly communicates what is the intent of this endpoint. Some other solutions that you will see for this type of problem is creating a completely new resource, something like an entries collection, which would be its own controller, and there you would define an endpoint identical to this one, except in a new controller and as a separate resource. This might be more aligned with REST if we are being dogmatic, but there's nothing wrong with the approach that I'm showing you here. One advantage, if we can call it that the second approach allows you to do is to properly return a 201 created response and include the location header in the response where you can specify the entry IDs in an array. But considering that for most use cases we don't really need this, we can just use our simple get endpoint to fetch back the collection of entries. So I think this would be overdoing it, and just exposing an entries batch endpoint is more than enough to implement this functionality. Now when it comes to how this works under the hood, there's a create entry batch DTO which accepts a list of create entry DTOs, which I'm using in the single post endpoint, and then back inside of the controller what we are doing is validating each individual DTO. Inside of the validator, you can define a rule for each of your items in a given collection, and I'm setting the specific validator to use the create entry DTO validator. So you can see how I can reuse code between my validators to implement a more complex validation approach. Then I need to check that the habits, which could be different habits that were specified for each entry, exist inside of my database and that they belong to the current user. If we run into a problem, we return 400 bad requests. Finally, I can just create my entries and persist them all inside of the database before returning the response. Now, I am simulating a 201 created response by pointing to the get entries endpoint, and really this is where you can find the specific DTOs, which I'm also returning as part of the response. So this is my pragmatic approach to implementing a batch creation endpoint. Now let's go ahead and test this out from the user interface. I started the REST API and the client application, and if I navigate to my entries, I can click on this button here that says batch create entries. And this allows me to define multiple entries that I want to create. So let's say course recording, and I will type a note saying recording batch create video. I will use today's date, and let's add another entry. Let's call it daily coding. I want to use a different habit for this example, and I can leave the note blank in this case. So if I click create entries, I'm going to land on the breakpoint in my create entry batch endpoint. And here I'm going to validate the incoming DTO, confirm that all of the habits exist, create the entries by simply doing a projection and calling toEntity and passing in the respective arguments. And finally, I can persist my entries in the database, and I'm going to press continue here. We'll get a response back in the user interface, and I'll be navigated to the list of entries. And here you can see my two new entries right at the top, because this is how I'm sorting the responses. We have my course recording entry, which is a manual entry, and then another manual entry for the daily coding. Of course, I can now edit this to add some random note, persist this, and all of this works as you might expect. So this was a quick demo of how you can approach implementing a batch resource creation endpoint in a REST API. This concludes our lesson about batch resource creation in a REST API. In our next lesson, I'll demonstrate how we can use HateOS for driving the behavior inside of our client application. Welcome to my next lesson, which is probably my favorite one as part of this chapter, where we are going to discuss how to use HateOS to drive the behavior of our client application. I want to focus on a few practical examples to demonstrate why hypermedia is a valuable concept of REST APIs. I'll start from the user interface, and I want to focus on the screen for fetching the habits for the current user. If I open up the Network tab in the Developer Tools and I navigate away from the screen and then back to the habits, you can see I get a request to the habits endpoint. Now the reason you're seeing two requests is because of how the Vite server runs locally. This isn't something that should happen when we go to production. Just something to be aware of for the demo. I'm not really calling this endpoint twice from the code. Nonetheless, what I want to focus on here is that we are calling the habits endpoint, and yes, we are doing pagination by setting the page size to 6, but look at the response that I'm getting back. It's the entire habit resource where I only need a couple of properties. For example, the habit name, the description, the target and the frequency, as well as the milestone, which might be optional and may not even exist for some of my habits. So this is a perfect use case for data shaping in our REST API, where we can only return the data that we need to render on the user interface. So if I go into the habits page component, I have a load habits function that is loading the habits from my REST API. And what I can do here is perform data shaping by specifying the fields that I want to return from the backend. Now this should be a comma-separated list of values, and what we need is the name, description, target, frequency, end date, and the milestone. I'm going to save this, and then let's go back to our user interface, and you can see that everything is still loading correctly. If we observe the Network tab, you will see there is an additional request here. It's being sent to the habits endpoint with an additional argument representing our data shaping fields that we want to get back from the API. So this is the complete request. It contains exactly what I specified inside of the component, and if we take a look at the response, you can see that our representation is now much smaller. It only contains the name, the frequency, the target, and the end date and milestone, which are all of the fields that I'm using to render this user interface. Our second response object contains both the milestone and the end date, which is the course recording habit. Now, what would happen if I tried to click on this habit to view the details? You'll see I run into a problem, and this is because I'm trying to find a habit of undefined. Now, if you ever wrote some code in JavaScript or TypeScript, then you probably realize that this is actually the undefined value, and this simply means I have a bug in my code. The reason this is happening is that my client application expects the response to have an ID. So if I go ahead and fix the data shaping to include the ID, and I go back to the habits collection, it's going to load correctly the same as before, and this time when I click the individual habit, I'll be able to navigate to the respective component. So the habit ID is missing from my data shaping response, and this is breaking my user interface. But remember that this shouldn't really be required for the client to work correctly because we are using Hypermedia. And for each of our resources, we have the respective self-referencing link that also contains the URI of the resource. So let me go back to the lists component. I will update the data shaping to omit the ID on purpose, and I'm going to make a small adjustment to my component. In these two lines of code here, I'm iterating over the habits that I get back from the REST API. I'm specifying the key as the habit ID, which may be null, and I'm also using it to construct where to navigate the client if this component is clicked. So if I can't use the habit ID because it may not exist, I can use Hypermedia to derive this behavior. So what I can do here is look at the Hypermedia links on the habit itself and find the self-referencing link. Because I only need the URI, I'm going to create a URL object using the href value, and then just take the path name and specify this as where I'm going to link to when you click on this component. So if I go back to the user interface, you can see that our latest request to fetch the habits doesn't contain the ID, but if I click on the individual habit, I'll be correctly navigated to the respective screen, and I'll be able to fetch the habit because I'm able to find the URI of the habit from the Hypermedia link. So I don't even need to include the identifier of a given resource when returning it from my REST API. All that matters is that I construct the correct Hypermedia links, and then the client will be able to integrate with this without too much trouble. A couple of more things that are going on here is that all of these links here are Hypermedia driven, and they're only displayed if the respective Hypermedia links are included in the response. I already demonstrated this in our first lesson when I introduced the client interface, so I won't do it again. What I want to show you next is how we can use Hypermedia to drive the behavior in our client interface. Let's say we want to introduce a business rule that you can only create up to 5 tags. We could and should include this logic in our REST API, but we can also inform the client that we have reached a state where we can no longer create the habits. And we can do this by simply omitting the respective hypermedia link in the response. So let me go back to the backend and I will make an update in the tags controller. The endpoint that's responsible for returning the collection of tags is the getTags endpoint. And what I want to do here is to adjust creating the hypermedia links for the collection response. This will contain the create link, which is pointing to my post endpoint on this respective controller. And what I want to do is pass in the number of tags that this user has. Because I'm returning all of them in the collection response, I can do this without any additional queries to the database. And now let's go ahead and define another argument here that's going to represent the number of tags. Let's call it tags count. And what I can do is omit the create hypermedia link from the response, and I can say if tags count is less than 5, then go ahead and include this additional link in the response. So now I'm dynamically determining if I should include some hypermedia link in the response or not. We could drive this behavior from our application settings. So this would be an improvement to the current implementation where we are able to configure the maximum number of tags that we allow each user to have. I'm going to leave this as a simple exercise for you to turn this into an options object, and I'm going to start the application and head back to my user interface. I'll go ahead and create a random habit with just a few numbers for the name, and you can see that we are sending a post request, getting back a 201 created response, and then sending another request to fetch the tags collection. And in the response, you will see that there is the create hypermedia link. Let me create another tag, let's say 1234. We get the response back again, and the hypermedia link is still here. But when I create my 5th tag and send a hypermedia link, the user interface suddenly changes. The response no longer contains the create link, and this is because I'm only rendering the form for creating a tag if the hypermedia link is present. So this is how my REST API can drive the behavior of my client application. If I go ahead and delete a tag, let's say I say delete, confirm this is going to send a delete request, which will remove the tag from the database, and it's also going to issue another request to fetch the tags collection. But this time, because we have less than the maximum allowed number of tags, the response will contain the create hypermedia link, and then the form is rendered again on the user interface. So I can go ahead and delete my dummy tags. I'll close down the developer tools. So hopefully you can now see how we can use hypermedia to make our client applications more dynamic and make decisions at runtime instead of when we actually write the client code. Implementing our client applications like this does require a bit more work. For example, if we take a look at the tags page component, we have to keep track if the respective hypermedia link is present or not. You can see how I'm fetching the create link here, and I'm using this on the user interface to decide if I should render the form for creating a link or not. So objectively speaking, it's not a large amount of code that you have to write for all of this to work. You just have to embrace a different mindset. Instead of having to count how many tags I'm getting back from the API and using this to determine if I should render the form or not, I can simply depend on if the create link exists or not. If it doesn't exist, I don't show the form. And the same goes for deleting or updating the habits. I'm referencing the respective hypermedia links and the response and using that to send the request to the backend. I don't need to know how to construct the respective URI for deleting a habit. I already get that information from the REST API. I hope you enjoyed this practical demonstration of how we can use hypermedia to drive the behavior of our client application. When you truly embrace this concept and start implementing it, you will see that it opens up some very interesting capabilities inside of your client applications. In our simple example, you saw how the client application doesn't need to know anything about the business rules. It can just rely on the hypermedia links. And then the REST API can drive the behavior by deciding when to return the respective hypermedia link or when not to return it. And based on this, the client application can make the decision at runtime if something should be rendered on the screen or not. In our next lesson, I'm going to do a quick introduction to the OpenAPI specification. It's something that we mentioned in the past, but we just briefly skimmed over it, and I want to discuss the topic of using the OpenAPI specification for generating HTTP clients.